Hello students, welcome back to the 7th video of this playlist. In this video, we will be solving question number 7 from the May 2024 Further Pure Mathematics, that is F1 paper. So this is one of the most recent past paper of Further Pure Mathematics. So let's get started with question number 7. At first, part A, here the question is asking to show that for all positive integers n, sum of 12r squared plus twice of r minus 3 from r equals to 1 to n, this is equals an cube plus bn squared, where a and b are integers to be determined. Okay. So this is basically summation equation. We have to simplify this summation equation. Okay. So for part A, we can write this summation equation as 12, take 12 outside the summation, sum of r squared from r equals to 1 to n, then plus take 2 outside the summation, summation of r from r equals to 1 to n, and then negative take 3 outside the sum. This is sum of 1 from r equals to 1 to n. Okay, so this is basically the left hand side. Okay, we don't need to write left hand side, we will just continue to simplify this summation equation. Okay, now this is sum of r squared, then sum of r. Okay, so where can we get the formula? Okay, so basically if you don't know the formula of this summation, that is sum of r squared, sum of square of the real numbers, sum of square of the natural numbers, sum of cube of natural numbers, you can get these formulas. For sum of square of natural numbers, this is the formula, sum of r squared, and the second one, it is for sum of the cube of natural numbers. Okay, so we will use these formulas. Okay, so at first it is 12 of sum of r squared. So sum of r squared, so sum of r squared, it is basically n times n into n plus 1 times 2n plus 1 over 6. This is the formula for sum of the square of the natural numbers plus twice of the sum of r. Sum of r is basically sum of natural numbers, which is n times n plus 1 over 2. Okay, and then negative 3. There will be n number of ones, so that means that would be negative 3n. Okay, now just simplify, multiply them out. So 12 over 6, this is basically twice of n into n plus 1 times 2n plus 1. Okay, and then plus 2 cancels out, you will get n times n plus 1, negative thrice of n. Okay, now from these these three terms, not two, there are three terms. From these three terms we can take n common. Okay, if you take n common, then you will get 2 into n plus 1 times 2n plus 1. This is from the first term. From the second term we will have n plus 1, and from the third term we will have only negative 3. Now just multiply out the bracket. Okay, so if you multiply out the bracket, what you will get, okay, you will get 2 times n into 2n. n times 20, it is 2n squared. Okay, 2n squared plus n plus 2n plus 1. Okay, plus n plus 1 minus 3. So that would be n minus 2. Okay, bracket closed. Okay, now multiply the first bracket. So you will get n times 2 times 2n squared, that is basically 4n squared. Then n plus 2n, it is 3n. 3n times 2, it is basically 6n plus 2, and then plus n minus 2. Okay, so we can write 4n squared plus 6n plus n, this is basically plus 7n, and then plus 2 minus 2 cancels out. Okay, so you will get 4n cube as you multiply the bracket with n plus 7n squared. Okay, so we got the value for a, it is basically 4, the coefficient of n cube, and the value for b, that is the coefficient of n squared, it is basically 7. And that's what part A of question number 7 has asked to determine. Fine. Okay, next is part B. In part B, the question is asking, hence, determine the value of n for which sum of r cube from r equals to 1 to 2n minus sum of 12r squared plus twice of r minus 3 from r equals to 1 to n equals to 270. Okay, so the question said hence. That means we have to use the answer from part A to approach this answer of part B. Okay, so sum of r cube from r equals to 1 to twice of n. So we have to use the sum of cube of the natural numbers. Okay, so this formula you can get it from the formula booklet. Okay, so for part B, sum of r cube. So sum of cube of natural numbers, it is basically from r equals to 1 to twice of n, right? So the formula is basically n squared times n plus 1 whole squared. So n is basically here twice of n. Instead of n, we will use twice of n whole squared. So n squared times n plus 1 whole squared over 4. If I'm not wrong, let me show you the formula and check it out. N squared times n plus 1. So here n equals to twice of n. Okay, because the question, the sum of r cube, they wanted from r equals to 1 to twice n. Okay, minus the equation that we found in part A, right? So this is basically 4n cube plus 7n squared. So minus 4n cube negative 7n squared, this is equals to 270. Okay, now multiply both sides by 4. So okay, before multiplying by 4, I think this 4 will get cancelled, because 2n whole squared, it is basically 4n squared. So 4n squared, and there is 4, so this 4 and that 4 cancels out. So you will get n squared times 2n plus 1 whole squared negative 4n cube negative 7n squared equals to 270. Okay, now expand the bracket. So you will get a squared plus twice of a plus b squared minus 4n cube negative 7n squared. This is equals to 270. Okay, now multiply the bracket. So you will get 4n to the power 4 plus 4n cube plus n squared negative 4n cube negative 7n squared. This is equals to 270. So in the next line, we will take 270 to the left side, and here we can see that 4n cube negative 4n cube cancels out. So you will get 4n to the power 4 minus, this is plus n squared negative 7n squared. So this is negative 6n squared negative 270 equals to 0. Now divide both sides by 2. You will get 2n to the power 4 negative 3n squared negative 135 equals to 0. So 100, is it possible to do middle term? Let's have a try. 135 times 2, it is basically 270. So 15 times 13, no, it's 195, 270. In that case, okay, we can use the quadratic formula. Okay, let's use the quadratic formula. So we will get n squared equals to minus b plus minus, like just compare this quadratic equation with quadratic equation. Okay, so n to the power 4. In place of that, it will be n squared whole squared. Okay, so that's why we are getting the solution for n squared at first. Okay, so that's why 3 plus minus square root of b squared. B squared is 9 minus 4 times 2 times negative 135. That is 1089. 1089 over twice of a, which is 4. So either n squared equals to 3 plus square root of 1089, it is basically 33 over 4, or 3 minus 33 over 4. So n squared equals to, definitely since it is squared, we know that square numbers are always positive. So 3 plus 33, it is basically 36. So 36 over 9, it is 36 over 4. 36 over 4, it is basically 9. So either n squared equals to 9, or n squared equals to 3 minus 33 over 4, which will give negative value. So we will ignore any negative values because n squared is never negative. So n equals to basically 3 plus minus 3, but we will consider only the positive value. So the value for n, for part B, we got n equals 3, and that's the answer for part 7b. Fine.